Hello everybody and welcome to part 4 of the Mystery Demo Tutorial Series. My name is Jason, also known as Pirate JC, and in this series we are going through step by step, diving in deep into each part of creating a demo together, except you have no idea what it is that we're actually building. We're revealing it as we go along. In our previous video, which you can find a link to in the description down below, we combined multiple Gerstner waves together to create a fluid-like but chaotic-looking simulation in the vertex shader. And today, we are going to dive even deeper into waves. That's right, you probably thought that we were all done with the mathematics behind waves. But we're not. And I promise by the end of this video, you will be so entrenched in the matrix of waves that you won't be able to find your way back out. In this video, I promise you, it's going to be a little bit longer. There's a lot to cover in this video, so stay with me. We're going to continue to go step by step, but we do have a lot to cover. So this is going to be a little bit longer, but that's okay. And there will be a stopping point in the middle for you to kind of stop and pick up and catch back up with where we are in the video. So without further ado, let's go ahead and dive right in. To pick up right where we left off from the last video, there's a link to the description to the NME session, the Node Material Editor session down in the description below. So here it is. And what we have is a chaotic looking, but like I said, very fluid and awesome simulation in the vertex shader to simulate kind of a fluid motion where we have multiple different waves operating together. And today what we're going to do is dive deeper by adding variation to each one of these waves. So how do we start with that? Well, before we actually dive into that, I want to say that we're pretty lucky because as we've been recording this video series, we actually have been still continuing to work on the tool. We haven't stopped, and so we actually have something brand new to show that's an advancement on something we showed in a previous video. So what we're going to do is let's open up one of our waves here. We'll go to Gerstner wave number 1. And we're going to go to this toggle. Now, previously, we set up this toggle by making it a slider between 0 and 1. And we're piping that into a step node. Now, this step node has an edge value of 0.5. So if the slider is below 0.5, then the step node will output 0. And if it's above 0.5, it'll output a 1. And we multiply that by each of the values in our vector 3 for the x, y, and z positions of each individual vertex. What we can do now, though, is we actually can tell this toggle not to be a slider, but we have this new feature called isBoolean. So what we can do is we can toggle on the isBoolean. In this case, I'm actually going to leave this one on. And then what we can do is rather than going into the step node, we can bypass the step node and go right into this scale node and use that directly as our multiplier. And now we can actually select these two nodes and get rid of them. We no longer need them. So we're going to do that very quickly for each one of our waves, okay? And actually, you know what I'm going to do? Just for good housekeeping, I'm going to take this one, each one of these kind of over here, so we're kind of away from some of the other nodes. And we'll open them up. That way, sometimes if there's lots of nodes on top of other nodes, it can get a little confusing as to what's happening. So we'll take this one, we'll set it to a Boolean. I'm going to turn all the rest of the waves off because primarily today we're going to be working with Gerstner wave number 1. And I'm going to take the output of that toggle, and again, I'm going to bypass the step node. And again, we can multi-select these by holding Control and delete that. Okay, so I'm going to put the blue one back for a minute, and I'm going to go ahead and grab the other ones. Feel free to follow along here each step of the way. Again, we're basically just taking these toggles and switching them into Booleans. The main advantage to doing this is we can actually save some compute cycles on the GPU by not having to compute whether or not that our variable, our toggle, is above or below this step value. And so that's actually really, really handy. Just another way that we can kind of continue to help optimize this shader along the way, because as we've pointed out, we're asking this shader to do quite a bit. And don't worry, it's going to get even more intense the further down the rabbit hole that we go. Okay, just kind of organizing these. Now you may notice that as we do this, the collapsed version of these frames actually gets a little bit longer. That's okay. As you dive into any given frame, the fact that the inputs and outputs change based on the rewiring of what you've done with your tree is totally expected. And it's actually a good thing that the frame actually adjusts accordingly. And so that's a very expected behavior. So the fact that these three are a little longer than those two is very, very normal and very, very expected. Okay, so continuing along the way here, change this one into a Boolean. Again, continuing to turn all of these off except Gerstner wave number 1. And oops, I forgot to bypass it. Let's bypass that real quick. And here we go. Oh, we gotta scoot over a little bit. Okay, and bypass the step node and kill off both of these two. Okay, and then we've got one more wave left to do this on, Gerstner wave 6. Last one here, and then we can start getting into adding variation right into our input values for each of these waves. The amount of math that's going to be driving these waves in the end is going to be overwhelmingly large. And I don't say that as a mean to scare you, but as a means to really say, you're going to be able to do something really amazing with Babylon and the node material editor by the time that we're finished. I mean, it's already amazing, but we're going to go even further. So let's start with our optimization here, with our kind of adding variation. Let's start by taking a look at wind direction. Now, the wind direction currently is positioned using a vector. And the way I described it before is by thinking about, do you want 100% of X and 100% of Z? If so, then you would put a 1 and a 1 in those categories. And based on that, based on the values that you put into this vector, kind of tells you which direction you're headed, the wind is headed. That's not actually conceptually the easiest thing to follow. And we can actually make it more simple. What if we were able to dial it in like a compass, where you could actually give it kind of a cardinal direction and say, I'd rather it be kind of north by northwest, something to that effect. And what if you had a little dial, so to speak, where you could actually make a slider that actually moved it around a compass? Well, we can actually do that mathematically. So here's what we're going to do. We're going to take all of our inputs for Gerstner wave 1 and drag them out of the wave. And then we can go ahead and we can collapse this, and notice that it does get longer, and again, that's expected. So what let's do is, let's take the wind direction and pull that up here. Now, to demonstrate what exactly it is that we're going to do, we're going to access another link that you can find down in the description below to look at some very, very basic plotting points of, we'll go over a cosine and a sine wave and how we're going to leverage those two together to make a circle. Now, this is some basic trigonometry here. If it's not familiar to you, don't worry, it's not too hard to follow along. So what we're going to do is I'm going to turn on a cosine and sine waves, and I want to point out something to you here. We have a cosine value of 1, and when we have that value, look at the value of the sine wave. It's 0. And the same thing is true with the sine wave. When it has a value of 1, the cosine is at 0. So these are inverse of one another. And this is something that we know. This is something that we've been taught. And so what we'd like to do is actually leverage a full rotation and be able to use the difference between these two as X and Y coordinates. And I'll show you how exactly we're going to do that. But first, what we'd like to do is have our compass go from 1 to -1 in Y and 1 to -1 in X. And so we need to be able to complete a full rotation or cycle in each of our waves to go between -1 and 1, whereas right now we're going between pi and -pi. So to do that, what we're going to do is actually do the same equation, but it's going to be x multiplied by pi. And so if you look just at the sine wave as an example here, you can see that it will complete, it'll go down, up, and back to the middle between -1 and 1. And so again, same thing, when cosine is 1, sine is 0, when sine is 1, cosine is 0. So that is exactly what we're looking for. In fact, if we actually take these and plot these directly in to the x for cosine and the sine equation for y, look at what we end up with. I'm just going to plot this point on here. And as I change this slider between -1 and 1, look what happens. We actually get a full rotation around this circle. So we can actually use this as kind of a compass bearing to say, here's north, here's east, south, and west. You can have any direction that you want. So this is what we're going to use to pipe into the node material editor instead of using our vector as our direction for our wind. So let's go ahead and do that now. So what we know that we're going to need is we're going to need some value. So we're going to grab float. Actually, we're going to need two of them. 1, 2. This one we're going to name pi, and I bet you have no idea what the value is going to be. Totally kidding. 3.14. For those of you who have memorized pi beyond that, don't get angry with me. We're just going to leave it at 3.14. And the other thing I want to do is I want to set this to be a constant. That just helps optimize the GPU, the shader on the GPU for later as well. Okay, so we need to multiply these two things together. There we go, and we'll connect them on up. And then the next thing that we need to do is we need to take both the cosine for x and we're going to need the sine for y. And we simply connect these up. Now we have x and y, but as we have with our vector here, we do need to combine these two into a vector. And so the way that we're going to do that is with our vector merger node. All right, so we're going to pipe this into x, and this is going to go into y so that we get the xy output for the vector 2 here. And then I'm going to drag this over a little bit just so it's easier to hook up. And I'm going to replace the two connections in the Gerstner wave 1 here. So we can drag this back and take a look at what we have. We now have, with this thing here, this variable, which actually you should probably give a name to. Let's go ahead and call this wind_dir. We're going to call it wind_dir. And I actually want this to have a minimum of -1 and a maximum of 1. And now it's a slider. So watch what happens when I adjust this slider. I actually am moving it all the way around. The wind direction is changing based on that cardinal direction of kind of the compass of where I want to head. That is much conceptually easier to understand. Hey, where do you want the wind kind of blowing for this particular wave? That is definitely something that's far, far easier to understand. But there's still a problem. This is a great optimization, so we can actually get rid of this vector 2. We don't need it anymore, and we can say add a little bit more variety there. But we're not quite done. There's a problem. There's more enhancement that we can do here. If you actually look at the direction of the wave, it's still completely linear. The wind is only moving in one direction. And as we know, wind doesn't do that in the real world. So we can actually use math to add variety. So imagine if we have our single direction, but what if we split it and used math to kind of oscillate between kind of two edge values? We kind of opened up a wedge and said we want the wind to kind of be in this general area, but not a specific finite direction. That would be really intriguing. And we can actually do that fairly easily by just referencing a very simple sine wave. Now this is also, the URL here is also down in the description below if you'd like to follow along and check this out. I've mentioned this in previous videos, but the Desmos.com graphing calculator is a super powerful tool to use when you're diving into creating shaders together. So let's see here. We actually have a very simple formula. It's sine of x minus t over w. So in this case, what we're going to do is I'm going to take time. Now, anytime that I see time, I automatically assume to myself that I'm going to multiply it against some kind of value. The reason for this is while time may work, I also may want to speed up time or slow it down. So I'm going to call this wind_dir speed, okay? And I'm going to multiply these two together. So I could use time. I could just multiply time by 1, or I could speed it up or slow it down based on the artistic dialing in of the specific waves that I want. To start with, though, we'll just stick with 1 and just say that we're going to use time and then use that speed as something we're going to encounter later. So I now have t, so I need to have x minus t. So for our cases, we're just going to go ahead and use 1. So what we can do is we can say, I'm going to go grab a float. I'm going to list that as 1 and call it x because that'll match our formula. And then I'm going to get a subtract node, bring that in, and I'm going to say 1 minus that output. So I can do that. That's absolutely representative of what's in the formula here. However, we can actually make that a little visually more simple because we actually have a 1 minus node here in the node material editor. So I'm going to bring that out. I'm going to connect this up, and visually it just cleans it up. Oops, I meant to connect the multiply. It just cleans it up a little bit more. So we can actually get rid of U, and then there we go. Much more visually easy to use, and the same exact operation. And it's actually no different on the GPU using that. Okay, so I now have x minus. I need to divide that by some variable w. So I'm going to get a divide node. I'm going to pull that out and connect it on up. And then I'm going to divide by this node, which I'm going to call w, and we'll give an initial value of 1. Okay, so next what we have is, so that's x minus t, and again, t in our case is multiplied by a speed multiplier, and then we have over w, so we just need to simply take the sine of that. So let's go grab another sine node, and we'll pipe that right onto the end. And now what we can do is we can actually move this back over here and replace the wind direction, and watch what happens. If you see this right here, it's actually moving in a full circle all the way around. So we're adding variety mathematically, but of course, we don't want the waves to constantly be going in a circle. We want them to be contained to kind of a distance. We want to say there's a low threshold and a high threshold, and we want you to kind of oscillate within this realm. So the way that we're going to do that is currently our sine wave goes from 1 to -1. And the very first thing that we want to do is we want to tell Babylon we don't care about below. We want to remap from -1 to 1 to 0 to 1. And so we actually have a remap node which will help us do exactly that. In fact, the default state is exactly what we want. It is -1 to 0 to 1. And so if I take that in and I pipe this in now, watch what happens. I'm now going to do basically a half circle instead of an entire circle. So we're getting there, but I still want to hone it in just a little bit more. And to do that, we're going to use one of my absolute favorite nodes. It's called the lerp node. If you're not familiar with this, it is unbelievably powerful. What it basically allows you to do is say, I would like to take these input values from here to here as I'm animating them, and I want to be able to correlate them as a gradient between two other values. So in our case, I will go get a float. I'm going to drag that on out. We'll grab two of them. First one is we're going to call wind dir low. And second one, you may be able to guess, we're going to call wind dir high. Now these two we're going to grab, move over here just to connect them on up. So we'll plug the low into the top one and the high into the bottom one. Doesn't really matter, but just make it a little bit more simple for ourselves. And we're going to drag these over so that now all of our new input properties for this new equation are kind of all over here together. Okay, and so now what I want to do is I want to say the wind direction we originally picked was -0.36. So I'm going to keep that as kind of our median line, and I'm going to expand on either side of that a little bit. So on the low side, we'll say that we're going to go to -0.45. -0.45. And on the high, we'll say that we're going to go up to, oh gosh, maybe -0.25. Let's kind of see how that looks. And how fast do we want that operation to oscillate between the two? We'll look at that in a second. Let's hook this on up and now look at the wind direction. So the wind direction is varying slightly, and it's changing, it's oscillating back and forth. And actually, to make that a little easier to visualize, watch this. We can actually increase the speed up to, say, 10, and there you can see the wind direction moving back and forth. Now that's pretty cool. We're starting to introduce some variety into this. We're starting to get some solid variation in the movement of the wind direction. However, that also is not really realistic to nature. Even if I slow it down, nature doesn't move that uniformly. And the problem, of course, with that is that we've given it a very simple sine wave. This simple sine wave is great, but it's not going to mimic something that happens in the real world. And so what we'd like to do is to add basically more noise, more chaos and variation to the mathematical formula that's driving that lerp, and then taking those two low and high values and piping that in and animating between them. So to do that, what we're going to do is actually reference our third Desmos.com calculator link and look at this beast. So this is an awesome wave, and while there is repetition in it, there's actually the appearance of a lot more variety to it. And it's actually not that complicated of an equation. So we're actually going to now create this in the node material editor. So the first thing that we notice is that we have x minus h. Now in this case, h and t, they're interchangeable. H here represents time the same that t did in our other one, in this one here. So they're the exact same. In fact, this equation, x minus t over w, it really is the same here and here. We're just using different values for w, and so we have b and r. So let's go back to our node material editor and look at what we have. So we have time, and the time is here, plus our multiplier over here. And then we have 1 minus that over, and in this case, for this side, we want to say that this is b, and b has an initial value of 1, as you can see right here. Okay, and so now what we're going to do is we have this side of the equation, but now we need this side of the equation. So we can reuse the x minus time, and we're going to divide by a different value this time. So let's take this up here, and this up here, and then let's grab these two and copy them. And so we can take this divide node here, and they're hooked up correctly now, but now we can say that we want this one to be r, and it has an initial value of 0.4. So let's give that a value of 0.4. Okay, and so now let's continue on, see what we've got going. So we now have the x minus h over b and x minus h over r. So we need to take the sign of both of those. So lucky for us, we have one sign, and now we can grab, just copy and paste actually if we want to, grab another one, and we need to hook it up to this side. So we've got the two sine waves now. And so let's go ahead and make a little bit more room for ourselves by backing up over here. And the last thing that we're going to need to do is multiply the result of those by a and q. So we're going to need two multiply nodes, 1, 2, and we're going to need two more floats, 1 and 2. Okay, so what we can do here is we'll hook this one up there, sine to the right, and then we're going to grab a value here and say that's going to connect in there. I think this is called a. Yep, so we'll call this one a, and it has an initial value of 0.5. Okay, so let's go 0.5 for A. Same thing with this one. We're going to hook up the multiply node. Doesn't matter which side it's in. We'll go left just for the visual organization of it. And then this one is going to be Q, I believe. Let's double check. Yes, which has a value of 0.3. And so we're going to hook this up here, and we're going to call this 0.3. Okay, and then the last step that we need to do, very, very simple, is just boom, add those two together. So we'll grab our add node, bring that on over, and connect that right on up. Okay, so this now piped into our input. With the speed up, you'll really be able to tell that it has a lot more variation to it. See how it's kind of stuttering and it's not exactly very, very smooth? That variation is this wave at work, which is awesome. And so what we can do is actually slow that back down to something far more reasonable, say 0.85, and you're going to get slow variation, but it won't feel like it's going back and forth. So now we have math driving our wind direction for us, which is awesome. Couple more quick cleanup things let's do. Let's take these 4 variables that we have here, and we're going to change the type to constant, because we're going to be copying and pasting this and using it again and again, and we don't actually need these values to change. We're fine using this exact wave over and over and over for all of our variation. And so the last one here, we'll change that to a constant. That is looking pretty awesome if you ask me. I'm just going to organize these a little bit. Now, everything that's in here is actually something that we can repeatedly use. This part here is specific to the wave, but going all the way out through the lerp, we can draw a frame around that to reuse it. And so let's do exactly that. Let's draw a frame right like this. And then we're going to call this one wind dir mod. And let's make it the exact same color. Since we're doing green, since we're on Gerstner Wave 1, let's go find green, and we'll kind of color coordinate all of our modifying frames. Okay, last thing that we're going to do is we have labeled these wind dir speed, wind dir low, and wind dir high. But I want to preemptively do something that's going to set us up for some success in the future. If we go to type on these three inputs here and we change the type to visible in the inspector, that's going to really help us in the future. And then for group, I'm going to give it a name of wave 1, and I'm going to go ahead and copy that. And so what I'm going to do is same thing. We're going to set this to be visible in the inspector. The group is going to be wave 1. And don't worry, we're not going to cover this in this video, but this is going to be something that's going to help us in the future. Okay, so what do we have? We have math, a decently complex sine waves added together to drive variation in the wind, and the wind has now been translated into compass directions, and we've piped that in for the vector 2 for the wind direction for our Gerstner node. How exciting is that? More math. We are going to be so deep inside the matrix by the time we're done. Yeah, your head's going to spin. Okay, now you can probably guess what we're going to do next. Let's copy and paste this because we're now going to change a different value. So we're going to change wind dir to amp, and we're going to change the amplitude. We'll go a little lower on our slider, but stay green, just kind of change the color to differentiate it a little bit. And this part is actually going to be fairly easy. What we're going to do now is just look at the amplitude. The amplitude has a value of 0.1 for this particular wave. And so if we use that as the middle and kind of go on either side of it, why don't we do 0.05 to 0.15? And so we'll take the low and we'll call that 0.05. And then we'll do the high and we'll call that 0.15. 0.15. Now, what I would like to do at this point is even though this is amp mod on our frame here, they still say wind dir. We do need to change these. This is important. This is something that down the road, even though it may seem a little bit tedious now, down the road, this is really going to save us a lot of time because we're going to want to dial in these parameters to really get the exact look that we want. And it would be really awesome if each of these we knew exactly what they were. We're still in wave 1 because this is still Gerstner wave 1 that we're modifying. So we have our low value and our high value. That's kind of the edges of the wedge for the amplitude. And then let's say that we want that to process at a different rate. We'll say maybe 1.1 just to kind of vary it up a little bit. And then what we're going to do is we're going to collapse that, we'll bring it over, and we'll replace everything that the amplitude is plugged into. The amplitude is plugged into 3 different places. You can kind of see them visually when I move this around. So the first one that we'll do is we'll go up here to this right node. Now they are all currently labeled right, and that's something in the future that we want to be able to change and edit, and we're going to add that feature as time goes on. But for now, we'll just kind of connect these on up. So let's grab this one and connect it to the last spot, which is right there. So now if we look at what we have, our amplitude is actually going to go up and down. You can kind of start to see it changing a little bit. There it's going up. And so our wind direction is being changed with that kind of chaotic noise sine function, as well as our amplitude. We're really dialing this thing in. It's awesome. And of course, what we have is more math. So that's the amplitude. This one is the wind direction here. And so let's actually clean up an unused node. We don't need this node anymore, so we'll get rid of it. And then what I want to do is take our amp mod, copy and paste. And you can probably guess what we're going to do here. This one is going to be for the steepness. Now the steepness is the last kind of preserved clear one. When we get to wavelength and speed, we're going to modify it ever so slightly. So we'll drop that down to about there, make it a little bit darker. And let's look at what our value for steepness is. It is 0.19, so if that's kind of the middle of the road, we go on either side of it. I'm going to go 0.1, and let's say we're going to go to 0.25 maybe, something like that. It doesn't have to be perfect, just kind of generally how steep, the oscillation of how steep we want it to be. And then I like to vary all of the speed. We'll make this one go a little bit faster. oops, faster would be 1.22. There we go. And then let's collapse this down and drag it over here to make it easier to hook up. And you're probably already thinking that I forgot something, and I believe I already did, which is renaming these. So let's stop and do that now. We're going to change this to be steepness. Again, this is a really important thing to do. Otherwise, you will beat your head against the table later. So you're saving future self some time and some effort. Trust me, it is absolutely worth it. There we go. Okay, now let's collapse this. And we're going to connect this in to where steepness is located, which is this left channel right here. So let's connect that one on up. There we go. And now we have variation as well in the steepness. Steepness is a little harder to see because it is very subtle. And again, we've talked about this in previous videos. We don't want to go too high, but let's just for the sake of visualizing it, set this really, really high. And so you can see it's really rounding out and it's going a little steeper again, back to round. So there you go, really steep and sharp. And so it is actually doing it, but we're going to just do something kind of low and subtle for now. Okay, so that is steepness. Now let's copy and paste that and open it on up to do the wavelength and the speed. Now, we're going to call it wavelength. These two are actually going to be connected. So let's change this down to kind of a darker green here. And let's look at what the wavelength is currently. The wavelength is 0.25. I'm going to use that as kind of the lower bounds. So we're going to say 0.25 will be kind of the low end. The high end, I don't want to go too much higher than that. Maybe we say 0.4, maybe something like that. And then the speed for this one, I'm going to say that it's going to change at a bit of a slower rate, maybe something like that. Okay, so the way that this one is going to work is we are going to add connect the end of the lerp directly to the wavelength. Okay, so we're going to connect it directly up here like this. And we're also going to use the same for the speed value because if you actually think about what's happening to this wave, and you can actually see it slowing and going backwards right there. What's happening is as the wavelength stretches out, it stretches out from the origin, which is at 0. And so it's actually stretching out in both directions, both in the direction that the wave is headed and stretching out in the opposite way. And so what we need to do is actually increase the speed and move it a little faster, but uniformly faster, so we don't end up with kind of some of this weirdness that you're seeing here of it going backwards, slowing down, coming to a halt. And so that's actually a result of the fact that we need the speed to be multiplied by a different value. So I'm going to bring in a float. I'm going to also bring in a multiply node. And I want to just simply take this float to connect here. I am going to call this speed let's call it speed multiplier. And let's give it an initial value. I find that 3 is kind of a general good value to start with. Okay, and so now you have the same result of this, so it's getting a lot of the same math, it's just increasing the speed so that it moves it forward faster, so as the wavelength changes, it doesn't feel like the wave is going backwards. Let me show you how this ends up looking. So here we have speed. Actually, let's get rid of wavelength because we're done with that, and we're also done with steepness. So speed is connected right in there to that second spot, and we're going to take the multiply, drag it on over, and replace it. And now watch our wave. Our wave is still going to slow down a little bit, but if we've dialed it in right, it hopefully should feel like it's still always kind of moving forward. And if you want to tweak that value, that multiplier right there is something that you can use. So we're not going to call that a constant just yet because we may modify it later. So there you go. Now we can actually get rid of that speed. And what we have is 4 different waves of this sine wave here driving randomization or variation in all of the inputs of our Gerstner wave. So I actually want to stop right here and open these up and just take a look visually at the complexity of what we're accomplishing here. There's a lot of math happening to accomplish a really cool looking pattern. And let's of course open up, we'll bring the toggle down over here. Let's of course open up our Gerstner wave as well. If I can click on it. There we go. Okay. So just at a glance, look at all of that awesome math. I love this. It's so cool to see all of that math driving the result of this and creating a lot of randomization. So we're actually adding variation to the wind direction, the amplitude, the wavelength, and then coarsely the speed as well. And then finally the steepness value. This is so cool. I'm loving this. But you probably guessed where this is headed, right? We're not done yet. We have 5 other waves to duplicate with this same exact setup. But before we do, let's actually modify one more thing. So we added a couple of extra nodes for our wavelength here, and that's actually technically for the speed. And then we've also, our wind direction also requires a little bit of extra things as well. So I tell you what, let's do. Let's try and see if we can get enough room to kind of compress these and make room for them inside of this frame here. So I'm just going to scoot everything over. Let me try that again. There we go. We're going to scoot all these over. It's not going to be able to super visual and easy to understand. It's not my my objective right now. I just want to literally make room inside of this frame for the extra nodes. And so actually these are pretty good here. We'll just drag these kind of up. And that, I think, should be enough room for all this. Hopefully. We can, actually one of these we're not even using anymore. Goodbye. Nice. Okay, let's move this over. Move these over, compress these a little bit, and then take this and move it on into the frame. And boom, now we have the actual modified waves for wind direction, amplitude, steepness, and then wavelength and speed. Okay, this actually is where we're going to be starting to, I'm going to pause the video here in a second, and I'm going to ask you to go ahead and repeat this process that we just did for each of these other nodes, okay? Now, there's a couple of things I'd like to point out. We'll go ahead and bring this one on over. The way to start this, I'll just get you started with this one. We won't go through it all together. We're gonna drag this over, give yourself plenty of space, okay? And then you're going to drag your inputs out. You can close up this after you've done that. And then you're going to copy and paste these frames, okay? So I'm going to click on one. Now you have to do these one at a time, and we'll move this over here. And then you're going to repeat this process for all of these. Now, there's a couple of important things you need to do. First, we're going to toggle off Gerstner wave number 1, okay? So that now we're only looking at, when I toggle Gerstner wave number 2 on, we're only looking at Gerstner wave number 2. I really think it's important at this stage to see the effect that you're having with this math on each individual wave, and then later we can add them together. So what you're going to do is a couple of things, okay? You're going to, WinDirMod is still a perfectly appropriate title, but we're going to change the color to match what we're on now. I believe it's blue, if I remember correctly. Yep, so we're in the blue category. And then these names are okay. However, this group name needs to change as well. Okay, so we're going to copy and paste this to each one of these. And you are going to rinse and repeat exactly what we've done each step of the way here and connect these on up appropriately. Just copy and paste, use all of the toggles, do the same process, and you should see this layout for all 6 waves by the time that we're done. Okay, let's go ahead and pause the video here and we'll pick up after you've done that. We'll be back in a minute. We're back. Okay, fantastic. Hopefully by now your node material session looks something like this one. Now, as this loads, you'll see there is a ton of math happening here. Look at this behemoth. It's massive. Oh, this is so cool to see all of this together. But actually, we're only seeing one because I only have one toggled on. I think that's this last one. So let's toggle all of them together and see what the result of all of our variation is. So I've colored all of these. I've added random numbers to them. The numbers don't really matter. It's just so that you can kind of see the effect. Make it look good for your own purposes. We're going to actually use them later as well, so we can dial them and change them later. But there you go. Look at this. That is so much variation that we've added on top of our multiple Gerstner waves. If you don't love this, something's wrong. This is so cool. But look how deep inside the matrix we are. If primary school Jason could meet this Jason, he would think he was nuts, that there's no possible way that this could have ever been learned. But we did it together. So this concludes part 4 of the mystery demo tutorial series. I hope you've enjoyed adding variation to your waves. If you have not already done so, please check out the other videos in this series, and please consider subscribing to this channel so you don't miss any future updates, and we'll see you next time.